Dear student, in this video, I will discuss about the circuit that is present in the amphibian physiology experiment. So this is the experimental setup. You can see. So in this experimental setup, you can see there are three types of instruments present. One group of instrument is the stimulating instruments or stimulating appliances that will help in this case we give the electrical stimulation, so that will give the electrical stimulation to the nerve muscle preparation. Another group of instrument, that is a recording instrument. So when we apply the stimulus, so there will be some contraction relaxation in the skeletal muscle, so that will be recorded by the another instrument. That instrument is a kymograph, we can see here. Another is that the instrument, some miscellaneous instrument are also present. Among them, in this experimental setup, we can find the mounting board, that is a myograph board with the stand. Okay, so here we can see the instruments which are related to the application of current, that is the electrical stimulation. So we have a current source, we have the keys, we have the Du Bois-Reymond induction coil and the stimulating electrodes. These are under the heading of stimulating appliances. Regarding the recording appliance, we have the kymograph, which is located we can see in this picture, and for mounting we have the myograph board with the stand. So in this experimental setup we have two circuit. One is the primary circuit, another is the secondary circuit. So what are the components of the primary circuit? It will start with the current source. So you can see here the current source, then it will go to the wires are going to the simple key. From the simple key it is going to the kymograph. From kymograph it is going to primary coil, and it is again coming back to the current source. So this is the primary circuit. Okay, so when this primary circuit is closed, so there will be current flow in the primary coil of the Du Bois-Reymond induction coil. Now regarding the current source, in the previous slide, in this slide you can see this is the current source. Another plug point is also attached here, which is directly connected to the kymograph muscle. Okay, so if, what is that actually? This current source, for the stimulation we use the 6-volt DC current or the direct current. It is supplied with a 6-volt direct current from a central low voltage rectifier plugged to the mains. Okay, but for the rotation of the drum or of the kymograph, we use the 220 volt AC current. Okay, it is exclusively meant for running the kymograph. Okay, it has nothing to do with giving stimulation to the nerve muscle preparation. So in the primary circuit, what we have the current source, simple key, then kymograph machine, primary coil, and again it will coming back to the current source. Okay, so this is the primary circuit. Now in the secondary circuit, we have the secondary coil, short circuit key, and the stimulating electrodes. Okay, so when there is current in the primary coil, so that will be induced in the secondary coil, and if this is a short circuit key which is in the parallel to the circuit, so what is the function of short circuit key? If it is on, so then there will be no current flow in the stimulating electrodes. Okay, in most of the situation it is kept on, so that there is no current flow and no tissue damage to the nerve muscle preparation. Only when you are ready for the experiment, you keep this short circuit, you make this short circuit key off, so that there will be easy flowing of current into the stimulating electrode. So in the secondary circuit, we have the secondary coil and the short circuit key and the stimulating electrode. Now what are the instrument attached in the primary circuit? As we see here, we have the simple key, this is an instrument. We have the kymograph that is attached, and the primary coil of the Du Bois-Reymond induction coil, it is attached. Whereas in the secondary circuit, the instrument that are attached, that is a secondary coil of the Du Bois-Reymond induction coil, short circuit key, and the stimulating electrode. So we can say Du Bois-Reymond induction coil is present both in the primary and secondary circuit. Primary coil is attached in the primary circuit, secondary coil is attached in the secondary circuit. Now, in this experiment, I have already told you that we are using electrical stimulus. There may be different types of stimulus, physical, mechanical, chemical, but here we are preferring electrical. Why? Because it is localized, it can be localized on the tissues and applied repeatedly without producing any harmful effect to the tissue. Now apparatus use that is very tidy, so therefore the process of stimulation, it can be easily controlled by make or break of a key or by using an electronic stimulator. So we can adjust the voltage, we can adjust the amount of current, pulses, how frequently we want to give the stimulation. So this can be well regulated, and the intensity duration can be easily and accurately controlled. And another point is that this electrical stimulus, it almost resembles the normal electrical signaling inside our body. So that is the reason we are using the electrical stimulation over here. Now there are different types of electrical stimulation. Electrical current, it can be rectifier current, it can be induced or Faraday current, it can be galvanic current. So rectifier current, it is obtained from the electronic stimulator instead of Du Bois-Reymond uh, um, coil, induction coil. If we use the student stimulator, then we will be using the rectifier current. Okay, here the duration and strength can be pre-selected. We can adjust the voltage and how long it will be given. Okay, how frequently it can be given, it can be previously selected. Second type of electrical stimulation, that is we are showing here, it is a induced or Faraday current. It is a short lived and does not cause any damage. Then the galvanic current. Galvanic current is normally used in all type of neurophysiological studies. For example, if you want to do the nerve conduction velocity study, so we use this galvanic current because unavoidable process of self induction prevents a sudden establishment of galvanic current to its full intensity. That's why it is preferred for all neurophysiological study. But here in this experiment, we are using this induced or Faraday current. What is the advantage of it? It is short lived and it does not cause much tissue damage. Now, what we can say that when this primary circuit is closed, okay, so if we look at the kymograph, at the base of the shaft of the kymograph machine, we have a striker. So when the kymograph drum is rotating, and at the point when the striker is touching the contact box, at this particular point, the primary circuit is closed and there will be current flow in the, if the simple key is on, then there will be current flow in the primary coil. So in this way you can say that the muscle is the shaft is rotating, and the point it is touching the contact box, at that point actually the primary circuit is closed. Okay, now so how the circuit is actually stimulating the nerve muscle preparation? So first you have to make the simple key on. Second, make the short circuit key off. Third is so the current is flowing and rotate the drum. So at the while rotating, when the contact box is touching the striker, the primary circuit is closed. So at that point there is current in the primary coil, and that current will be induced into the secondary coil, and that if the short circuit key is off, this induced current will be free flowed by the stimulating electrode and it will stimulate the nerve muscle preparation. Thank you.